Hello, testing, 1, 2, 3, test in a new headset. Yeah, good. All right, thank you. Hi. It's getting close, yeah. I think we're 2-3 minutes out. This one is, the other one's not? Okay, but okay, there's access, so. Okay, thanks, Del.
My name is Matt Lundberg, and I am the director of Calvin University's DeVries Institute. I want to take this opportunity to welcome you here today. Quite a few of you here in person, including a number of you who have gone a long way through some snow, so thanks for making the extra effort to come to Grand Rapids. And also a welcome to all of those who are joining us through the live stream. We're also glad that you're here, even though we can't see you at the moment. Let's open with prayer. Gracious Creator, Father, Son, Spirit, we are thankful for the life you've given us, for the world that you've made, the world that we inhabit. We're thankful that we can explore this world using the tools of science, and we are grateful that you are at work in the world. Bless us today as we think about how those things fit together. Grant us understanding and insight through the research and the words of our speaker. And in all of that, as we seek understanding, keep us mindful of the fact that your world is made in and through Jesus Christ, for Jesus Christ, and it all holds together in him. So it's in his name that we pray. Amen. So I mentioned the DeVries Institute a minute ago. The DeVries Institute is Calvin's most recent, newest center or institute. The full name of the institute is the DeVries Institute for Global Faculty Development. So we do faculty development focused on faith and learning. Some of that is with Calvin profs, especially newer faculty, and we also develop some resources that folks have used around the world. And the point of it all is to try to figure out how Christian faith matters for the various things that teachers and scholars do. So with that mission, the American Scientific Affiliation is a great partner for an event like this because they have been at that kind of work in the sciences and technology for a long time. So it's a privilege for the DeVries Institute to be able to co-sponsor this lecture today with the West Michigan chapter of the ASA. So I'd like to introduce a colleague who will come up here and say a few words about the ASA, and then introduce our speaker. Professor Ralph Sterley is an emeritus professor of geology here at Calvin, and he is also the president of the West Michigan chapter of the ASA. So, Rob, welcome. Rob is over there. Ralph, welcome.
We're extremely grateful to the partnering work we can do with the DeVries Institute and for the encouragement that Matt, in particular, and Margie Stife, who works with Matt, have given us. So just a few brief words about the ASA, and then I'll introduce our speaker. The American Scientific Affiliation is the full name of the ASA. We have a sister institution up in Canada that's like the CSCA or something like that. It was founded in 1941 as originally as an international organization. It still is an international organization of Christians in the sciences, despite its seemingly parochial name. The members are required to subscribe to the Apostles' Creed and the Nicene Creeds of faith, and they also have a sort of an official stance that the members are people who believe that mainstream science is where it's at. We're not interested in trying to be fringe people out at the fringe. Okay. We put out a journal. It looks like this. It's called Perspectives on Science and Christian Faith, Journal of the American Scientific Affiliation. It comes out 4 times a year. It will probably go to 3 times a year because of some societal responsibilities or stuff. Students may become members for free. And so I mention this because it's something that many of you in the audience could do for free, and then you get a digital copy of this journal for free, so you can read all the articles. The only additions you would get if you paid dues were to get the paper copy of the journal and voting rights. So if you want to vote and replace people, then you've got to pay your money. Okay. I'll mention to anyone who wants to become a regular member, so that would be anyone who's not a non-student or a student who wants to become a full member. There is a special deal on right now until the end of March. It's a half-price membership dues offer. Okay. So if you would like to know more about the ASA, I'm happy to talk, and several other people here will be happy to talk to you after the event, and if you want, you can look at this. Okay. So I'd like to introduce our speaker, Jeff Koperski. Jeff's a good friend. Jeff teaches at Saginaw Valley State College, kind of a sister or maybe a rival to GVSU across the state, nearly all the way across the state. And Jeff was raised primarily in Ohio, the state of Ohio. He got his bachelor's degree in engineering at the University of Dayton. And then he went on and got a PhD in philosophy from Ohio State. And then he began to look around after that point, and very quickly a good opportunity emerged. There was an opportunity here at Calvin, but it looked a little bit uncertain. But an opportunity emerged at Saginaw Valley, and he took it. That was in the late 90s, and he's been there ever since. He has published extensively on the interface between philosophy and Christian theology. His first book is called The Physics of Theism. So he has many articles, but 2 books. Physics of Theism, God, Physics, and the Philosophy of Science came out in 2015. And then more recently, the book that ties in with the topic of today's talk, and its full title is Divine Action, Determinism, and the Laws of Nature. Okay? The ASA, in addition to sponsoring the talk primarily, will also, some of us will be going to dinner with the speaker. I have room to slide in one more student, just one only. So it'll be first come, first serve. So if anyone would like a free dinner and the opportunity to talk with the speaker, if you're particularly anxious, then that would be the chance. After the talk, we will take questions and answers. I'll serve as the moderator. Matt Lundberg has a handheld mic, so he can move to wherever someone would be standing with their hand up, and then we'll take questions in their turns for the speaker. So if there are not any, if I left anything out? Okay. Did I say that Jeffrey's from Ohio? Oh, okay. He got his PhD at Ohio State, which is, what can I say? Being a Michigander, I'm not sure about that, but at any rate, we love him nonetheless. Okay. Thank you, Jeff.
All right. Thanks very much. Thanks for being here, including students who were bribed to be here with extra credit. Okay, so yeah, we all do this. Okay, so it's not just you guys. It is an honor to be here, so my thanks to the DeVries Institute for sponsoring the whole thing. Special thanks to the ASA for the invitation. If I lived on this side of the state, you'd see me a lot more often, okay? But, you know, I came in yesterday, so I didn't have to fight the snow, so I'm glad to be here. All right, so let me just launch right in. I am betting that you believe there are laws of nature, and I think that's because you can't do much in the way of physics or chemistry without bumping into a bunch of laws. So you might wonder, what are we doing here? Why a whole talk on what is a law? I mean, you know what a law of nature is. High school students know what a law of nature is. So what exactly is the big deal? Well, using something doesn't mean you understand what it is. So, you all use computers. I don't know how many of you know a lot about binary code and transistors. You don't need to know about that stuff to actually use the computer. Same thing with Newton's laws. You can use it without knowing exactly what it is. And what it is a philosophical question. What exactly is a law of nature? Is it an equation that you find in a physics book? Because physics changes over time. Do the laws of nature change over time? That doesn't sound right. So I think we're going to have to look a little bit more carefully at what a law of nature is. But before that, before we're jumping in, let me pose one other question. Why should you care? So in some areas, again, many of you are probably engineering students, and there's some scientists. There's a diverse audience here. But in many of the areas that you're in, you don't even talk about laws. If you're in biology or something like that, you might think more in terms of mechanisms and causal networks and things like that. So why does the nature of the laws of nature, why does that matter? And the answer is, if you're in the sciences, then for most of your day-to-day work, it really isn't going to matter all that much. It's not that different. If you are in biology, then the different. What's true? Is it string theory, right, or loop quantum gravity, or something else? Again, if you're a biologist, it doesn't matter, right? The answer to that isn't going to impinge on your work. You might be interested to know. You just might be curious. But as far as or you might not. Either way, it doesn't matter. It's not going to affect your work at all. So the same thing is true here. If all you care about is how this stuff applies to your research or your next paper, I'll just tell you that it doesn't. okay? But the ASA invited me, and they're a Christian organization, and this is a Christian university. So many of you are interested in the relation between science and religion. And at least the professors are here, the science professors. You've been asked about that on occasion. And the laws have been a kind of a mixed bag when it comes to that particular question, because we've come to think of the laws as once you've explained something in terms of the laws of nature, then you don't need God anymore, right? As if the two were competing explanations. We'll see about that further we go. The topic is also important if you want to understand the history of science, because as we'll see, the ancients and medievals did not believe in laws of nature, that there were laws of nature. And the philosophical shift that happened from the medieval period to the modern era, that was a key part of the scientific revolution. It's the underlying philosophy that really is a driver to that. So if you want to understand the rise of modern science, pay close attention to the notion of laws. So again, should you care? Well, it depends. Will it matter for your next research paper? Well, probably not. Does it matter in terms of understanding science and how it arose in the first place? Oh yeah. Yeah, it's actually one of the most important things that you need to understand. All right, so let's get into it. As I said, the ancients and medievals, they did not believe in the laws of nature. Now, how can that be? I mean, how can I say that? Because they knew about the changing seasons. They invented astronomy, right? They knew that nature was regular and consistent. So how can I say that they didn't believe in the laws of nature? Well, look, the question here isn't whether nature is regular. Yes, they absolutely knew that. The question is what's responsible for that regularity. And my claim is that the ancients did not think it was laws. It was not the laws of nature. In their view, people make laws. So law belongs to the realm of politics and governance, not nature. That's a whole other thing. So what is responsible? What did they think? Well, one answer goes back to Aristotle. Aristotle believed that every substance is the combination of essence and matter. And so essence is what provides structure to reality. So rocks always fall, fire always rises, all triangles have three sides, every horse is a mammal. Why? Why is that always the case? Well, because each substance, again, has an essence that makes it that sort of thing and then gives it its capacities to act. This was the metaphysical system that was developed by Thomas Aquinas and others in the 13th century. But a lot would change in the 17th century. And the first big change was the rejection of Aristotelian metaphysics away from essences and towards a brand new idea, the laws of nature. And there were two main reasons for this. First, the notion of essences came to be thought as just scientifically useless. Newton called them occult entities, by which he just meant that they were unobservable. You couldn't see them. And the chemist Robert Boyle said it isn't even clear what it is. What are we talking about when we talk about an essence? Another reason was theological. So Aristotelian essences are if they are responsible for order in nature, then it seems like they're running the show rather than God. But the question arose: Does God need other things? Does God need intermediaries to govern for him? Can't God do that himself? And Newton and a lot of his contemporaries thought, no, yeah, God can do it himself. Isaac Barrow said this, one of Newton's colleagues at Cambridge: God uses no other means, instruments, or applications in these productions than his bare word or command. We have a lot more to say about that here in a little bit. Okay? One more thing, the medievals didn't do a whole lot of experiments, and there was a reason for that. They thought that if you want to discover the essence of a thing, and that was what was really important, you have to let it behave naturally. So don't interfere with it. So drop rocks and let them fall in and watch what they do. That's very different from, say, taking a rock and you can put a rock on a table and you can push it with your hand, but the rock doesn't want to do that. That would be considered violent motion against the nature of the rock. And how do you know that? Because when you push the rock, you take your hand away, it stops as soon as you take your hand away. Right? You drop a rock, it'll keep going until something gets in the way, because that's natural motion. That's what it wants to do. It doesn't want to move sideways. Well, in their view, experiments to do an experiment almost always produces violent motion. You're putting objects in odd situations and then forcing them to behave contrary to their essence. And so from an Aristotelian point of view, that was useless. You can't learn anything about the essence of a thing if you're imposing violent motion upon it. Okay, so it's not to say that no one at all ever did an experiment, before Descartes, but they just didn't have a lot of value. Once you had the shift away from essences to laws of nature, then everything changed. Everybody starts doing experiments, and then empirical science takes off from there. There's one other theological issue here. Most medieval theologians in the West believe that God also has an essence. It's not just rocks, not just horses. God has an essence. And his essence restricts his choices. So since God is all good, God can't do anything that's intrinsically evil. Since God is all wise, he only acts in a perfectly rational manner. But not everybody believed that. Not everybody believed that. There was a minority group. It was known as voluntarism. The voluntarists believe that God is free to act any way he wants. He can do really whatever he chooses to do. So in fact, God chooses to be good and merciful towards us. Nothing makes God or constrains God to behave that way. Now, that was an interesting debate that happened a few hundred years before Newton. The reason I'm bringing it up now is because voluntarism reemerges in the 17th century, but now it has to do with the laws of nature. Because the idea was that whatever the laws are, whatever laws God chose, he didn't have to choose that exact set of laws. God had a lot of options to choose from, and it wasn't a forced choice. So it wasn't a matter of God's perfect rationality. It wasn't a matter of God's goodness. God just chose from a bunch of equally good options. Now there's an epistemic problem then that presents for us, because how are we going to figure out what choices God made? You can't infer it from theological principles because God just chose, and God's not telling, right? He's not giving it to us by special revelation. So what do we do? Well, the solution was, again, empiricism. We can't discover the laws by way of reason, but God gave us the ability to make observations and do experiments. So yes, we can know the laws of nature, but we've got to do the work. It's up to us to go out there and actually discover what they are. So what this shows is that empiricism itself had a theological motivation. So again, God had ordained the laws. He could have chosen others, and the only way for us to find out what God has chosen was by way of experiments and observation. So empiricism itself is rooted in this change from Aristotelian essences into the laws of nature. All right, so that part of the story ends in the 1700s. By that time, pretty much everybody agreed, yes, there are laws of nature, and they thought that they had been decreed and ordained by God. So one question you might ask then is, well, what happened, right? Because that's not how we think about the laws today. Now it's a completely secular notion. Kids start learning the laws of nature, when they're in middle school, and God is very seldom, if ever, a part of that conversation. So how did that happen? How did we get from this theistic notion of laws to the one we have today? That is a good question. That's also another talk, okay? So I can't give you the whole answer to that. I'll tell you this much, though. It was not an accident. In the late 1800s, the notion of the laws of nature was intentionally co-opted away from theism into so-called scientific naturalism. So got a paper on that if you're curious about how that went. For now, I want to shift away from the history, and I want to talk more about where things stand today. So I want to talk about different approaches to the laws of nature in the philosophy of science literature. And I'm going to then ultimately try to defend one particular position. In the end, I think actually Newton was pretty close. Newton and his contemporaries pretty much had it right, although I'm going to tweak things just a bit. That's jumping ahead. Okay, so there are three main approaches in the literature on the laws of nature. I'm going to introduce them really fast, and then I'll go back over the details. So the first one takes a law to be a repeating sequence of events. So this is just like, you go out and you observe the orbits of the planets, and then you summarize that data in something like Kepler's laws. And that first view, it's called a Humean view of laws. The laws just are the regularity. The regularity itself, that's all there is to a law. So it's not a misprint. It's Humean. This is after the philosopher David Hume. I gave an abbreviated version of this talk by Zoom in Pakistan last weekend, and they had the automatic transcription on that you can do with Zoom. When I looked at the recording later, I noticed that they had changed Humean to human. So at one point in the talk, I explicitly deny being a human. I don't think that necessarily helped book sales in Pakistan, but nonetheless, there it is. So anyway, the Humeans, they deny that the laws in any way govern reality. They're just, again, summaries of things that we observe. So it'll be a very minimalist view of the laws. Second, dispositionalism. That says that there are things, the dispositionalists believe there are things that control events. They just don't think it's the laws that are running the show. The laws are not responsible for the regularities in nature. They say instead it's something that's internal to things themselves. And these internal things are sometimes called dispositions or causal powers. And then finally, there are those who think that the laws themselves are a fundamental category within metaphysics, and we'll call them nomological realists. So nomos there is the Greek root for law, and then realist means that in some sense or other, the laws are real. They are out there to be discovered. So three big families here, the Humeans, the dispositionalists, the nomological realists. There's a lot of diversity within each one of those, but I hope to give you just enough information so you can see the strengths and weaknesses of each one. All right, so let's say a little bit more about Humean laws. This is the view of most philosophers of science, so far as I can tell. I think that's because many of my colleagues don't like metaphysics. I do. I'm somewhat of an exception, but they prefer something more minimal if you can get it. So the Humeans believe in occurrent events, like when a system evolves from one state to another. Anytime there's a change, that's an event. But they reject the idea, again, that laws in any way govern reality. That's because nothing, on their view, governs reality. There is no sense in which nature has to behave one way rather than another. So on the older Humean view, the regularity theory says that the laws, they are just descriptions of perfectly regular events. So water freezes when the temperature drops below 0 degrees. There's a regularity. Air flows from high pressure to low pressure. Salt dissolves in water. All those sorts of regularities, those are laws. But again, nothing makes that happen. Nothing makes one event follow from another. There's no sense in which salt has to dissolve in water. So Hume himself said that any feelings that you have, that some effect has to happen, there's a cause, and then there's an effect. That sense of having to happen, that's actually a psychological projection on your part. So you see the two events, and then we impose the notion of causation. But really causation is an illusion. There are just the events, and there's nothing else. So this is a metaphysically simple view. There's no causal powers. There's no laws out there in the metaphysical landscape. There are just things behaving in regular ways. And they say that's all science needs. So, scientists don't care about metaphysics. They discover useful regularities, and some of those they call the laws of nature, and that's it. End of story. Now, there are several well-known problems for this type of Humeanism. And one of them is one big problem is trying to figure out which of the regularities count as laws. So all metals conduct electricity. It sounds like a law. All American presidents are men. That has been true. That doesn't sound like a law, right? And the question is, well, what makes the first one a law? Because they both have the exact same logical structure. So how do you set apart the laws from the non-laws? And you might think, well, that can't be that hard. I mean, we should be able to come up with some conditions, right, to say what the laws are. And people tried for decades. Philosophers tried. And it turns out there just aren't any. There's no good set of conditions, no criteria that lumps all the laws in one bucket and then all the non-laws in another. It just can't be done, so it seems. Another problem with regularity theory is it doesn't seem to describe how laws actually work in science. So you talk to cosmologists, and they have no problem talking about alternative universes, other possible universes where there are, say, no particles at all, or say where there was a big bang and then quickly there was a big crunch afterward, and the whole thing is just, matter has recollapsed back on itself. And the reason they're able to do that is because they know how our laws would apply in those circumstances. The problem with the regularity view with alternative universes is, all the laws are these regular sequences of events. So in a universe, say, that only has one particle, the events in that universe would be completely different. But if the events are completely different, then the laws are going to be completely different, because all the laws are sequences of events. If the laws work the way that the regularity theorist says, really cosmologists should not be able to talk this way at all. They shouldn't even be able to say, they shouldn't have anything to say about what goes on in another universe, because the laws are going to be different in that universe. Our laws don't apply in those alternative universes. So my point is just that physicists, in fact, assume that the laws, in some sense, transcend events. There's more to them than just regular events. We can talk about other possible universes with the same laws, and that's because the laws, they do more. They do make nature regular, and they can't be reduced to the regularities themselves, regularities between events themselves. So this first version, regularity theory, it's kind of died out. You really can't find many people who hold that view. Instead, things have changed to what is now called a best system approach. Okay? And so here's how it looks. So say that reality is made up of individual events, lots of individual events, kind of like, a spark starting a fire. Any change is an event. All those events together are called the Humean mosaic, which is why I've got the mosaic up there. Each tile stands for one specific event. And then say we have a sentence, we have a group of sentences, one sentence that describes each event. That's a lot of sentences, right? Because you've got a lot of events that you've got to try to describe. So to try to organize all that, we try to come up with a deductive system where we can try to derive as many truths as possible from a fixed set of axioms. So it's a lot like Euclidean geometry, right? You got axioms, and you derive a lot of truths from those axioms. That's the kind of thing that they're looking for. And then finally, we choose the deductive system. We got different possibilities. We're going to choose the one that has the best balance of strength and simplicity. So we want as many truths as possible, but we want to be able to use it. All right, so on this best systems approach, the axioms in that deductive system, those are the laws of nature. Okay? They're just propositions, special propositions that organize all the facts, because that's what the laws do. So says the Humean. The laws don't regulate, they don't govern, they aren't out there to be discovered, they're just a special set of propositions. All right, so even though this whole story, it's kind of an idealization, because we don't know the Humean mosaic, and we can't actually come up with the axioms as they really are. It's supposed to justify our practice in science. The idea is that what we have in our textbooks today, those laws are going to be pretty close to whatever the axioms would be in this ideal system. So it justifies our use of and calling the things in the textbooks laws. So look, for a hardcore empiricist, this is actually really great, because all you really need to believe in is the Humean mosaic. That's it. Everything else kind of is a matter of organizing that mosaic. So if you're skeptical about metaphysics, okay, like this is your view. This is absolutely the view that you want. Okay, so I think, some of you are probably okay with that, because when you hear the phrase law of nature, you immediately think of something that, like, you've seen in class, something that's got a name, right? Like Boyle's law. You could point to it. I want to suggest that you should not be satisfied with that, though. There's an important ambiguity in the phrase law of nature, and we jump back and forth, and so it's actually hard to catch. We need to distinguish laws and law statements. Laws and law statements. So a law statement, that is what you find in a physics or chemistry class. This is something you could write on a whiteboard and point to, like the ideal gas laws. The laws themselves, if there are any, are the actual laws of nature, the things that scientists are trying to discover. So the laws can't be wrong. They just are whatever they are. A law statement, on the other hand, well, they're descriptions of laws. So at any given point in history, a law statement, something in a textbook, it could be right, or it could be falsified somewhere down the line. So to understand the second Humean approach, it really summarizes just to this. There are no laws of nature. The Humean says there are no laws of nature. All that there are law statements. Those axioms in that best systems approach, those are law statements. So if you don't like this view, if you feel like there's got to be more to it than just this, it's because you have this intuition that the laws do more, that in some sense the equations in a textbook, that's not all there is to a law of nature. In some sense, the laws govern reality. And the Humean will just tell you, you just need to get over that because there are no laws of nature out there. There's just law statements. That's it. All right, well, those of us who are not Humeans believe that they are ignoring the real question here. Because what we want to know is why? Why does nature have these regularities? Why don't electrons ever attract each other? Why does gravity work the same way here as it does in other galaxies? In short, why is nature so often uniform and regular? And the Humean will tell you shouldn't ask those questions because there's something illegitimate about the question itself. If you think those are actually perfectly good questions and they deserve an answer, you're going to need a different account of laws. And so the other two non-Humean accounts, they agree there are answers to these questions. When a law statement is true, there's something that makes it true. There's something out there in reality that makes it true, something that keeps nature running on course. All right, so much for the Humean, though. Let's get to the second view, dispositionalism. So the second account says that there is something that keeps nature uniform, but it denies that it's the laws of nature that do it. So what accounts for the regularities we see in nature are causal powers or the dispositions within each entity. So take something like salt. Salt's got a lot of dispositions on this view. It has the disposition to dissolve in water. It has the disposition to attract other bits of matter by way of gravitation. And lots more. Every entity has got all sorts of dispositions in it on this view. And if you recall what I said about the history of science, dispositions might sound a lot like Aristotelian essences, right? Something inside each entity. And if you are making that connection, well, you're right. Dispositionalism is the philosophical descendant of Aristotelianism. So dispositions on this view, they are active powers, and they ensure things, they keep nature on track. They ensure things that behave, that everything behaves in a particular way. So like the Humean can't guarantee that, say, electrons won't start attracting each other in the next 5 minutes or so. The dispositionalist says, no, we can guarantee that because causal powers, dispositions, they don't change. So not only do electrons, as a matter of fact, not attract each other, that they cannot do so. They have the disposition to repel, and that can't change. So if you think there's more to the laws of nature than just these Humean law statements, this is a step in the right direction. Dispositions, they're out there to be discovered. In my opinion, it's only a step in the right direction. This is a very popular view among metaphysicians and philosophers of religion. It's a somewhat less popular view among philosophers of science. So let me try to say why. Two problems. The first one is the history of science, one more time. Dispositionalism represents, again, an approach more like what Aristotle had in mind. There are some very good philosophers that hold this view, but I've always found it a little bit odd. As I said earlier, Aristotelianism was intentionally rejected in favor of this law-centric approach. And then that opens up things like experimentalism, which is, kind of a big deal, right? The Aristotelian version of dispositionalism hindered the development of modern science. So here's my question. If dispositionalism, if it were right all along, why did we need to get rid of it to make such progress in science? If it were right all along, why did we need this new idea in the 17th century, the laws of nature? And the dispositionalist doesn't have much of an answer to that question. But that's really not the most important issue. The main worry that philosophers of physics have is that dispositions they only seem to work when it comes to laws that involve changes of state. When one thing, like Newton's second law, that one thing changes from one state to another. Their dispositions seem to work. So a dispositionalist can say why electrons tend to move when they get close to each other, because they'll say it's the underlying disposition of electrons to repel. That's fine. But there are other sorts of laws of nature. There are other laws than just dynamical laws out there. The physicists will be familiar with the principles of least action. You've all at least heard of conservation laws, like the conservation of energy. What does the dispositionalist say about those sorts of laws? The answer is they don't have a lot to say. Both conservation laws and principles of least action, they put constraints on behavior. They don't move a system from one state to the next. But that's what dispositions do. Dispositions can say, when you put salt in water, here's what will happen. Or when you drop a rock, here's what will happen. These other laws, least action, conservation laws, don't work like that. They constrain action. They don't push stuff along. If you didn't follow that, perfectly, that's okay. The dispositionalists themselves acknowledge that this is a problem. They acknowledge that when it comes to things like conservation laws, their account doesn't fit that very well. So it's not a straw man. Okay, it's a legitimate problem. Okay, so why is this view so popular? I said, a lot of philosophers like this. I think it's because dispositions, it's kind of intuitive. Newton's laws are familiar, and you can translate Newton's laws into disposition talk. Dispositions, moving stuff along. Conservation laws, principles of least action, those are less familiar, and they often just get left out of the conversation, I think. But I think that's a problem. If you're going to try to replace laws with these dispositions, you got to cover all the laws. You got to be able to tell us about how all the laws work, not just cherry pick a particular set of laws. Okay, so as I said before, three main approaches. We've done the Humean view that says there really are no laws of nature, there's just law statements, and they don't govern or really do anything. The dispositionalist says there is something that governs natural events, that they think it's dispositions, not laws. The third family takes laws more seriously, and so this is nomological realism. Okay, the realist says the laws have their own metaphysical standing, so they aren't just law statements. The laws are what law statements are trying to describe. So if you have a law statement, if you have something in the textbooks and it's true, it's the law of nature that makes it true. So there are two things, laws and law statements. So the laws are real in some sense. What are they? What's the ontology here? You will not like the first answer, but this is the one that most philosophers are familiar with. So let me run through this one real fast. Consider a law statement. All metals conduct electricity. All metals conduct electricity. That's true. What makes it true? Well, in this view, the terms metal and conductor, they refer to properties, or what philosophers often call universals. And when one property necessitates another property, which just means when you have the one property, it makes the other one come about, then you have a law of nature at work. So if a thing is a metal, it has to be a conductor. When one property necessitates another, you got a law of nature. That's what a law is. Now, some of that seems okay. I mean, we all believe that there are properties. Things have properties like mass and length. But what about that other thing that I tried to sneak by you? Necessitation, right? What is that? That seems like a good question. It seems like it's an important kind of thing in this whole account. And we do think that some properties do bring about other properties. But what is this necessitation relation? I do not know. I don't know. The whole property necessitation schema fits nicely with other things that metaphysicians like to talk about, again, like universals. It doesn't fit all that well with real science, so far as I can tell. And honestly, I think there's a lot of stuff like that in philosophy. When I first started reading philosophy, the philosophy of science literature, I had a very hard time connecting it with the physics that I knew. It didn't seem to mesh very well. Many philosophers of science today, they know a lot about science, though. In fact, three of the best philosophers of physics that I know personally did their undergraduate work here at Calvin. NYU philosopher Tim Maudlin was not one of those three, but he's got an interesting proposal. It's B, primitivism. So Maudlin has said this, look, the notion of laws, it's such an important and useful idea. Let's just start there. Instead of trying to explain the laws in terms of universals or dispositions, right, let's just take them as basic. We should just accept that there are laws of nature and just forget about any sort of analysis. Just take them as fundamental building blocks within our conceptual scheme. Now, you might think, it's cheating, right? You can't just, just say, let's just use this stuff, okay? Don't talk about it anymore. Let's just use it. Here's the thing, at some level, we all have fundamental assumptions about reality, what reality is like. So you probably believe that causes always come before their effects. You probably believe, there might be an exception, I see, there might be, okay, we'll talk. You probably believe you are not the only conscious being here in the auditorium, okay? Hard to prove either of those. There's just no getting around the fact that you can't have proof for everything that you believe. So given that, Maudlin thinks, yeah, look, laws of nature, look what work they've done for us in the last 300 years. Just accept that there are laws of nature. Okay? Now again, if you think that's cheating, I get that. Here's what I like about primitivism. First of all, I agree that the idea of laws is really important. It's one reason why I'm not a dispositionalist, because they want to replace laws with dispositions. And I think the Humean view is just too weak. I think there are laws, not just these law statements. But I don't think we have to take them as basic. I think we can say more. We don't have to settle for primitivism. So let's start with a different question. Where did the notion of laws come from in the first place? Well, if you've been paying attention, you might have noticed something. When I talked about this move away from Aristotelianism in the 17th century, theism played a really important role. So let me remind you what I said. The leading thinkers at the time, they were theists. They didn't like Aristotelianism. They didn't think that God needed these essences to govern creation on God's behalf. And most of them thought that the laws were just patterns within God's will for how nature must behave. Now, as I said before, is a very different view of the laws than we have today. When we teach science or the history of science, there's seldom any mention of God. I don't know, is it different at Calvin? Does God come up in the science classes from time to time? Every once in a while. Okay, so things are different. I teach at the state school, okay? God does not come up in the science classes. So like I said earlier, we often take laws and God as competing explanations, as if once you've explained something in terms of the laws of nature, you don't need God anymore. The early moderns would have just been utterly confused by that. They would have said, look, you can't have laws for the whole of nature without God. They don't compete. It's all in there together. And having looked at all the options, I don't think we can do much better than Newton and his contemporaries. I think the laws just are God's decrees for how nature must go. So philosopher Alvin Plantinga, a couple of you might know that name around here, I don't know, maybe. Alvin Plantinga calls this type of nomenological realism decretalism. Decretalism, the laws are God's decrees. Of course, if you're not a theist, right, this is not an option, but I am a theist. So let me try to make a case for this, and then I'm going to try to extend it beyond a little bit from what the early moderns had in mind. Okay, so I'm going to argue that the laws of nature are God's decrees. You might wonder where that fits among the three, right? Among the three big groups. I say it fits here with nomenological realism, but again, I told you that the nomenological realist believes that the laws exist, but here I say that the laws are just God's decrees, and God didn't create any powers or entities that are the laws of nature. Again, it's just God speaking. So in what sense do I actually? Am I a realist? In what sense do I believe the laws exist? And the truth is, I don't have a great answer to that. When you look at the three, you got to put it somewhere, and it's not. The Humean thinks there's just law statements. Dispositionalists replace laws with dispositions, and then the nomenological realist takes the laws seriously. Decretalism doesn't fit in the first two categories, right? Because decretalism says there are laws, right? There are not dispositions. And the laws are something more than just these regularities. So it can't be a Humean. It's not a Humean view. So either I put it in with nomenological realism, or I give it its own category. And I really don't care that much, right? Maybe it is sui generis, meaning it is its own thing. Either way is fine. I think it fits better with realism. All right. So decretalism, it is a minority position today. No doubt about that, but it has some positives. So first, it is a form of nomenological realism. So again, I think it's in the right camp. It takes the laws seriously. Second, decretalism is a conservative position for theists. What I mean is we already believe in God, so I don't need to believe in any extra stuff in order to make sense of the laws. I don't need dispositions. I don't need universals. All I need is God. And then third, this decretalism has history on its side. One of the confusing things when you get into this literature is we've been talking about the laws of nature for 300 years, right? And so you might get the idea, because it's the same phrase, that we're all talking about the same thing. We are not all talking about the same thing, right? There's lots of different views of laws floating around in the last 300 years. So when Newton and his contemporaries talked about laws, mostly what they were thinking of is, again, these divine decrees. Now, that doesn't mean we have to believe, the same thing that they did. And if there's a better understanding of laws out there, then I would take it. I just don't think there are any better views. Everything else has got, a whole slew of problems. So I'm actually happy to adopt the view of laws that launched experimental science in the 17th century. So why aren't there more of me? Why isn't Christian philosophy just filled with decretalists? Well, first of all, most philosophers, of course, aren't decretalists because they're naturalists. They only believe in entities that can be studied by the natural sciences. But I do think it's interesting that they have trouble doing without the notion of laws. Because here's the odd thing, right? Everyone agrees it was originally a theological idea, right? That's not a controversy. The laws came from a lawgiver. So if naturalism is true, it seems like they shouldn't have anything to do with the laws, right? It's like it's like a student who thinks that ethics is just a social construction, just kind of something we agree on, but then also thinks there's some reality about things like justice, right? There's a truth about justice. That's not an outright contradiction, but it's an odd fit, right? The two don't fit very well. I think that's the same way when it comes to the laws of nature and naturalism. It's not a very natural fit. But that's a bit of a rabbit trail, so let me get back to decretalism itself. Humeans, my Humean colleagues will complain that we don't have any more epistemic access to God than we did to Aristotelian essences. So we got an epistemic problem here. And there's some truth to that, I think. But I have independent reasons for believing in God, and that includes the belief that God created physical reality. So I'm not inventing the idea of God in order to account for the laws of nature. Okay? Decretalism is not and was not a God of the gaps explanation, for those of you who are familiar with that terminology. So the early moderns, they derived their belief in laws from theism. They just said this is the kind of thing that a theistic God would do. It's just a very natural position to adopt if you believe in a creator God. Okay? So in fact, I turn things around on the Humean. I say, yes, okay, look, decretalists, we have a larger ontology. Humean naturalism is simpler, more parsimonious, but I can solve problems that the naturalists can't. So one of the big ones, this is a problem I didn't bring up earlier. Humeans have a hard time explaining why we should trust induction. So the sun has come up every morning through recorded history, so we conclude the sun will come up tomorrow. And every piece of metal we've tested so far has been a conductor, so the next piece of metal probably going to be a conductor. So the question is then, well, why can we trust those sorts of inferences? Why is that? How do we know that the future is going to keep looking like the past? And the nomological realist, including the decretalist, will say, well, it's because these events are law governed and the laws don't change. The laws keep everything on track. The Humean can't say that. For the Humean, nothing keeps things on track. Nothing ensures that electrons won't start behaving really differently tomorrow. In fact, every law statement in the textbooks might stop working tomorrow. The best the Humean can say when it comes to induction is, hey, we've used it for a long time. It's got centuries, and it seems to have worked really well, so we should just keep on using it. Okay, but notice that's a circular argument. What it says is that we can trust induction in the future because induction has worked in the past. That assumes that the future will continue to look like the past, and that's the issue here, right? That's the thing that's kind of in question. To say that induction has worked in the past, and so it will work in the future, that is an inductive inference. Okay? So it's begging the question. David Hume himself raised this this problem in the 1700s, and humans have been wrestling with it ever since. Decretalists, we have an answer. Okay? We have a reason for why you can trust inductions, because there is something that keeps nature on the rails. It is the laws of nature, in this case, God's decrees, that keeps nature uniform and regular. Electrons won't start doing weird things tomorrow. All right, so again, the decretalist has an answer to the problem of induction. The Humean does not. If you don't like that answer, that's fine. You got a better one? It's hard. All right, now there's a problem. Problem lurking that I haven't brought up. It's one more ism. I know there's a lot of isms. I try to keep them corralled in the talk. I hope it's not overwhelming. One more ism. A lot of the early moderns thought that the decretalist view of laws, God's decrees, implied something called occasionalism. There's only a few philosophers here that probably know what that is. But the idea is this. First, the idea that the laws do govern physical reality. Rocks fall because of the laws of motion and gravity. But if the laws are just divine decrees, then God governs physical reality. So it's really God that causes the rock to fall. And according to occasionalism, that's how all change happens. So it might seem as if my hand, I'm scared to do this, I'm afraid I'll just knock it off. It seems like my hand pushes the pointer along, okay? But what really just happened there for the occasionalist is when I went to push it, God stepped in, God intervened and caused the pointer to move. Actually, God moved my hand for me because I can't move anything and neither can you. God always steps in to produce any sort of change. There's no such thing as natural causation. And it's not both and. It's not me and God pushing the pointer along. It's just God. God steps in to produce all change. That's occasionalism. Now, when I first encountered this in graduate school, I think I might have chuckled a bit. I'm pretty sure I chuckled a bit because it just seems so absurd, right? Like when I'm typing, it's God who's pressing the keys. Right? It isn't me. It's God stepping in to press the keys. I hope there are some other options because that does not seem very attractive. But historically, at least, decretalism about laws tended to slide into occasionalism. And there are a few philosophers today who still hold it. Plantinga is one of those. Alvin Plantinga is one of those. Now, in my book, I deny occasionalism, but not everybody's happy with that. As you can imagine, not everybody likes decretalism, and some have been trying to pin the occasionalist tail onto the decretalist donkey. That's me. And here's the thing: if my view of laws entails occasionalism, it's going to be much less attractive, right? So the question then will be, how do I get out from under that? If I don't want to be an occasionalist, how do I block that? Well, now I'm going to take you to some really cutting-edge stuff in the philosophy of science. What I and a few others have pointed out is that most philosophers assume that the laws of nature, they govern events, and that's the language I've been using through this whole talk. That the laws, whatever they are responsible for change. In the literature, people often say that the laws are the source of oomph, right? The laws, they push stuff around. It's a technical term, literally. You see this all through the philosophy. Oomph, okay? But some of us deny it. Some of us deny this view that the laws govern, that they push things around, okay? All right, so then, like, what do they do? What do the laws do? The laws, instead of pushing stuff around, they constrain. They constrain. So let's consider conservation laws again. Conservation laws, they do not say how a system evolves over time. They don't describe changes of state from some set of initial conditions. What they do is place constraints or limits on how systems can change. So if you take like conservation of energy, it allows for any change at all within an isolated system so long as the total energy remains constant. It puts limits on how things can change. So under an oomph-free nomological realism, the kind that denies governance, all laws work kind of sort of like conservation laws. They place constraints on how things can change rather than providing impetus for change. So let's take something like Coulomb's law. Okay? And I'm going to drop the distinction between laws and law statements here. And I know there's some physicists out there. And so physicists, I know it's really a vector, okay? I know this is not one of Maxwell's equations. So, you know, and I know the story I'm about to tell is highly simplified. Just let me save the partial differential equations, okay, for another time. Is that okay? Yeah, good. But as I think it works, let me have my toy story here. Coulomb's law. Coulomb's law describes how electrostatic force repels like charges and attracts opposite ones. There's the thing. That law could have been different. Electromagnetism could have been a little bit stronger, and so Coulomb's constant would have been larger. There's all sorts of ways that law could have been different. So what the law of nature is here, what the law of nature that Coulomb's law refers to, it constrains electrostatic force so that it acts in just the way it does. So it can't be a little more or a little less. It can't be something different on Tuesdays. It can't be something different in the far side of the galaxy. It's all the same. And notice that this is kind of an important thing. It's electromagnetic force that attracts or repels electric charges. It's not the laws of electromagnetism. That's going to be an important part of the story. The laws constrain whatever it is they apply to. The laws themselves do not create change. The laws don't provide oomph. Okay, so what does? What does account for change? Well, here I think physics pretty much has that wrapped up. Physics will tell you about forces and momentum and energy potentials. Those are the sorts of things that physics appeals to when it talks about change. And I think that's plenty good. That's all we really need. When philosophers tell me, no, we need more. We need another layer on top of that, something that provides oomph. I don't get it. I don't see what we need. I think there's plenty of oomph at the level of physics. So again, the laws constrain what they apply to. The laws do not move stuff along. Okay, so I believe decretalism, I should say, I believe is best understood in this oomph-free sense. The laws are God's decrees, and what God has decreed are constraints. Okay? So unlike the early moderns, unlike Newton, I deny that the laws involve dynamic production. The laws themselves, they're not causal. The laws don't push stuff along. What the laws do is ensure the uniformity of nature. They keep natural processes on track. All right, professional philosophers are not supposed to quote C.S. Lewis. Like, don't tell anybody. But here's a passage from God in the Dock that I ran across just last week. In the whole history of the universe, the laws of nature have never produced a single event. They are the pattern to which every event must conform, provided only that it can be induced to happen. But how do you get it to do that? How do you get a move on? The laws of nature can give you no help there. The laws are the pattern to which events conform. The source of events, what moves stuff along, must be sought elsewhere. So in other words, the laws do not move stuff along. They have, as Lewis says, never produced a single event. So this is a constraint view of laws. It's in Lewis. Between Lewis and Del Ratch, there's not a whole lot that's completely original to this talk, it turns out. I'm just pulling it all together. Okay, so how does this help me then? How does all this help me? Well, look, occasionalism, you go back to the problem view, occasionalism presupposes the laws themselves bring about change. And if the laws are just divine decrees, then God is the source of all change. This is how decretalism tended to slide into occasionalism. But if you deny governance, if you deny the laws are causal, then the laws just constrain change. In that case, God's decrees don't move systems from one state to the next because we don't really need it. Physics pretty much has that taken care of. It's explained at the level of physics. But if God isn't directly causing change, then we're not talking about occasionalism anymore, right? If God isn't stepping in to nudge things along, then yeah, I've done it. I've freed the view from an occasionalism. from occasionalism. So no, I'm not an occasionalist. I think I don't have that burden of that particular view. All right, so big picture then. Let's try to pull this all together, wrap things up. God is the creator. God brings about the Big Bang. As part of creation, God decrees the laws of nature, right? So even before there are atoms or forces, God decrees how it is they're going to behave. Like charges have to repel, they have to repel in a particular way. He sets the strength of gravity and all the other forces, and on and on and on. God sets the constraints for how natural systems can behave. And those constraints are what we call the laws of nature. Okay, so unlike other nomological realists, I don't think the laws govern, where govern means the laws are pushing things around. I don't think the laws push things around. They're not like forces. They're not like causes. The laws constrain. By the way, if decretism, I don't know if this occurred to you, but if it sounds vaguely like let there be light, and then there was light, that is not intentional. That was not like my goal to give you a Genesis 1 account. But I can tell you that Old Testament scholars who I've talked to about this view, they really like this view. They like decretalism an awful lot. All right, so now you know more about the laws of nature than you ever wanted to know. Too often, theologians, I find, when they jump into questions like divine action, meaning like what God does in the world and how God does it, and they talk about the laws of nature, but they just assume like that everybody knows what they mean, and we're all talking about the same thing. And as we've shown, right, there are lots of different ways of understanding the laws. 200 years ago, decretalism was the majority view in the West. It is not currently popular among philosophers. It does have the distinct advantage of being true. That's a joke, so anyway, you don't have to hold my view on this. But I would very much like to see its strengths recognized. I don't think it's a coincidence that this view of laws played the major role in the scientific revolution. And insofar as the notion of laws continues to be important in science today, I think that decretalism should be taken seriously. All right, that's it. I am done. Thank you for your attention.
So we now have some time for questions. Remember that Matt will have a mic he can take around, and we'll be happy to hear them. And I may ask for you to repeat the question if I don't quite understand it myself. So thank you.
You want to point me to the people you're seeing?
Yes. Dale, right here.
Thank you for the presentation. So I'm sitting at my keyboard.
Yes.
I'm typing.
Yes.
If laws of nature do not determine which key I hit next, what does?
Well, in that case, then I also believe in free will. So part of it is you, right? Part of it is your intention, right, to hit the keys. What the laws are going to do on this account, right, is make sure that when you touch something, when you press down, that it's going to conform to something like the laws of mechanics, right?
So you're saying there's something in me that's not governed by the laws of nature that gives me free will, and what would you call that something?
What will I call that something? That's you, right? That's whatever it is to be a human being, to be a human person. Yeah, I believe that person has free will. Again, some people are going to say it's a soul or a mind, an immaterial thing, and others are going to say not. Is that what you're pressing on?
Yes. Could it be a spirit in me?
Yeah, I'm fine with that. Right. So that this is a very traditional view. This is actually one of the problems that another problem with laws that I didn't talk about was the issue of determinism. Right, determinism. In Newton's time, all the laws were deterministic, meaning you put in the initial conditions, and it tells you exactly how things are going to go. Okay, and everything is law governed. All particles are law governed, and they all have to go in a particular way. And so the worry was that, well, if that's true, and so like my body and your body is also made up of particles, and it's all got to be Newton's laws. I mean, where is there room for free will in the universe, right? If Newtonian mechanics is true, one traditional way out was the belief in mind-body dualism. That yes, we have bodies, But we also have minds or souls which are immaterial. They're not made of atoms, and they are not subject to the laws of nature. So there's more at work than just the laws. So that's a very traditional way of accounting, making room in the universe and reality for free will, even if the laws of nature are, in some sense, running the show.
Can I take Dale's question one step further?
Sure, sorry,
Okay.
me.
I don't own a dog. I'll go home and cry about that. But I don't own a dog. But let's say I did.
Yeah,
And the dog meets me at the door when I come home, and it's very excited and it's jumping in the air. Newton's laws would constrain how high it's going to be able to jump.
sure.
But they may not necessarily have to do with like when and where it decides to jump.
Constrained but not determined, right?
Yep. So the dog has, to an extent, some freedom of action.
I think so. I don't know how far you can go down the chain of being,
Right.
where things no longer have free will. But dogs, yeah, I'm happy to think that Descartes did not, right? Descartes thought that animals were completely mechanical and that they just looked like they have free will. I'm sure, yeah, animals have free will. Yeah, I'm fine with that. Yeah.
Yep. Okay.
So the laws, again, they constrain, but they allow for an awful lot, right? So no, you can't levitate, okay? You can't do that. But I can toss you the water bottle, and that's completely up to me, whether I do so. So yeah, I like free will. Got a whole other talk. I can do another talk on free will. Okay, so yeah, big defender of free will in light of physics. Not every physicist does. I've got interesting quotes. There are a lot of public-facing physicists these days that want to say, yeah, kind of like what I said about Newton, but even in the age of quantum mechanics and relativity, there just is no room for free will, and I think they're wrong. I think actually, yeah, no, there's plenty of room. But yeah, you gotta see where it lies.
As a physicist, I appreciate your comments. In particular, when we teach the laws of physics, we have a hierarchy of laws. A hierarchy of the laws. Sure. Because we start out by talking descriptions of motion, which would basically be Humean, talk about what the law is for velocity as a function of acceleration. And then we move from that to the dynamics to the forces. So we get to Newton's laws. And then the third level is the conservation laws. And we always say that the highest level is the conservation laws. And so then we can then derive the lower level of laws from the higher level laws. And I think the way that you did at the end by saying that the laws of nature are constraining, that's exactly what conservation laws do. So I think it's very compatible with what we consider the highest level of laws in physics, and very compatible with what you're saying about that the laws of physics are actually constraints.
No, it's great. That's a lot of help. I would not have thought of it as in that hierarchy. So no, that's very helpful. I appreciate that.
I really appreciate the presentation. This is a topic that I want to spend more time searching, and I love so much the presentation. Thank you so much. And I have a question. I understand the thing that it's connected to the laws of nature as regularities and things like that. But sometimes, as a physics too, sometimes we assume something in the nature like the postulates for quantum mechanics and the principles for the conservation of things. So how can we deal with these kind of things in this view that the laws of nature are God's will for all these things?
Not sure I understand the question. So I use simpler laws. I talk about Newton's laws and Coulomb's laws, but you can go to today. We can talk about Schrodinger's equation as being a law. Schrodinger's equation, again, to be precise, it's a law statement. You can write it and you can point to it, right? But if Schrodinger's equation is true, right, then there is a law of nature that makes it true. So I think it scales, right? I can go to all the more complicated, whatever true physics is, right? I think true physics at the end of the day will be law governed, right? And we're trying to discover what those laws are. I just don't go to the more complicated examples because I don't need them, right? And not everyone's familiar with them. That answer your question or not?
Yeah.
Okay.
Yeah. Thank you.
How does decretalism respond to contradictions or seeming contradictions between science and faith?
Oh, well, it bridges them in part, right? I mean, because the laws of nature, we think of that as a scientific idea, right? You learn about the laws of nature in science classes for the most part. And I'm saying that the best account for what the laws are actually involve God. And even if I'm wrong, if you go back historically, right? So the people who actually give us the scientific revolution, that was their view, right? That they thought when they introduced when Newton and Descartes and others and Boyle introduced the notion of laws of nature in science, for them this was a theological idea, right? This is the implication of theism itself. So in terms of there's no dichotomy here between faith and science. It all fits together. So in part, I think it's a really nice bridge. In part, I like this example. I like the history just to show that that science itself, the history of science, is thoroughly theistic, right? You don't get modern science in its current form. You don't get the notion. I mean, take a counterfactual world where there was no God. I don't think you get the idea of the laws of nature, right? Laws would not have been invented. That idea would not have been invented without theism. Okay? But with theism, you get laws, and everyone agrees it's a pretty handy. It's a pretty handy idea, right? We've been using it successfully for 300 years. So I think it actually helps bridge the two. It shows that it is not the case that science and religion have, as some people will try to say, have been in conflict or at war for 300 years. That's a very recent idea. The conflict thesis is, I would say, just false. Like, you don't find people who specialize in science and religion. Like, I don't know of any who hold the conflict thesis now. It's still popular out there in the culture because it's a nice way of like beating up on people like us, mainly beating up on people of faith. Okay, but no, I don't think there's a tension.
Yeah, thanks very much, Jeff. I have to confess being criticized for having a woefully unexamined metaphysic, which I can now say, in your terms, I am a naively contented Humean.
Okay.
And so I'm hoping you can help me advance in that. So I am unconcerned about the problem of induction that you were talking about.
Okay.
And the reason is, I think as you described the best set of law statements, with the best explanatory strength, with the most simplicity, they don't tend to have that all the laws changed at 4 o'clock on a Saturday afternoon.
Right. Yep.
That tends to be more complexity than necessary, and also not a pattern we've seen anywhere else. So I will actually, put my coat on when I go outside, not expecting it to be 95 degrees, because I don't expect actually the laws that govern climate and weather to suddenly change while I'm in this room.
Yep.
So that's just my best bet.
Yeah.
If I have to make a prediction about the future based on my best law statements I have, and it's the same reason that I will choose this resistor over that one for this circuit, or these other things that I do. So I'm untroubled by induction, so help me become more troubled.
Well, it's just a matter of, if you aren't troubled by it, then I'm not sure that you really are truly a Humean about the laws. Or maybe that you're just overconfident, put it that way. Because the Humeans, like I said, back to Hume himself, they recognize this as a problem. Because again, all that's going to exist for the Humean, ultimately all that exists is that Humean mosaic. It's just individual events. Even just, it could be one popular version of it is just different properties of space-time, individual points in space-time with individual properties that might change. And then that's it. There's nothing more to reality than just that. And so in the mosaic, whatever we've experienced in the past, whatever regularity you want to point to, again, it's because there's nothing. The tiles in the mosaic. They don't. Whatever order they have, we're bringing that order to them. It's like a constellation, right? We see some sort of pattern. Is there really a pattern? Well, no. I mean, there's stars, and even something like Orion's belt. That some of those bodies are way farther away than others. We impose a pattern on them. For the Humean, that's what we're doing. We call laws of nature. We're imposing a pattern on those tiles. But across time, yeah, there's no reason to think that things won't be radically different, in the next second. So we're really just we use induction because, like, well, what else are we going to do? It's like we don't have another tool to replace it. But if you're at all worried about it, right? Maybe again, if you're not, and I'm not sure how to get you worried. But we are kind of just getting lucky, right? That nature happens to be as regular as it is, because in the human mosaic, nothing enforces any structure on it. It can do any number of things. Electrons can start expanding to the size of the sun tomorrow, and that would just be another event. So I don't know. I don't know if that helps at all. But it's it's anything goes. So we're kind of lucky that things are as nice as they are, that we can do science and sit on chairs and like so. So over here, Ralph. Just go here.
Hello.
Hi.
So the idea of like the oomph-free laws, at least from what I was understanding, sort of like seems similar or might lead to the idea of like the divine clockmaker, where God sets the original constraints and then is really hands-off and just watches things happen. Would you like argue against that interpretation, and what's your response to that?
The oomph-free view, you say?
Yeah.
Yeah, I see what you mean. Yeah, so this is only, most of what I talk about today, it comes from two chapters in the middle of my second book. What I am pressing on towards at the end, though, is an account of what philosophers and theologians call divine action, meaning like what God does post-creation. Okay? And so, no, I'm not one who is, that God just winds up the clock and lets it go. I mean, if God wanted to do that, then it would work, because once God makes the decrees, it all works. Okay? But it doesn't prevent God from then acting within the physical world. So it's a both and for me. I do think that God. So there is this thing at creation, right? Part of creation itself is God's decrees for the laws. But then within history itself, God can still act. So I'm actually part of the motivation for the book is to try, and I can't give you the whole story here, but to try to find a model of divine action, meaning how God works, where God doesn't have to break the laws of nature, but there's still a lot of freedom for God to do things. That's like the big picture, what I'm after for the whole book, because there are a lot of people that are working on this notion of divine action, and they have different models for it, but they all think that God, for various reasons, just would not break his own laws. But then God is very constrained under that. If that's what you want in your picture of divine action, my worry is that God just can't do much. And I think God can do a lot. It's really up to God, right? But I want there to be a model that allows for, at least the possibility of God actually. So it's the polar opposite of the clockmaker. I think God does a lot, but I think God can do it surprisingly without breaking the laws of nature. I know that sounds a little bit weird, but you got read two chapters ahead of what I talked about today, and I'll sketch it for you.
I have a related question to the previous one with regard to, does God change or violate his laws of nature? Jesus walked on water.
Yeah.
And we sometimes, for example, pray that somebody who's on death's door with cancer will be healed, and sometimes they are. So does that not involve changing, suspending, violating the normal laws of nature?
Yeah. I don't think it has to. I guess I am going to say more. You don't have to read the next. So here's how it goes. Here's the short version. All right. Am I breaking the law of gravitation right now? Am I breaking any laws? No. And if you had a stream, and you got a stream on campus somewhere, is there running water around here somewhere? You do? Okay, so there's a stream, right? And there's laws of fluid mechanics that are going to govern how that stream behaves. Now, if I take a big rock and I toss it into that stream, the stream's going to change, right? Did I break any laws of nature did I break any laws of fluid mechanics when I tossed the big rock into the stream? The answer is no, right? I didn't break any laws. I don't think the laws of nature ever break. But the laws flow, if you want a slogan, right? The laws don't break, the laws flow. And we make a change. We have free will, going back to your first question. We have free will, and we make changes in reality. We never break the laws of nature. The laws adapt to the changes that we make. The laws we don't ever have to break any laws. We don't have the power to break any laws. I think it works the same way with God. God can introduce a change. God can hold up Jesus, right, on that water and introduce a force, and then the relevant laws that are operating with the water, like they'll adapt. They'll adapt to that. God could literally, put something in the water for Jesus to stand on, and just like me throwing the boulder into the stream, right? The laws will adapt to that. They don't break. So I think anything that we can do, anything that we can do with our free will, I think God can do that too, and not break the laws of nature. So that's my short model on divine action. If for some reason it doesn't work, my drop back position would be violation. It would be that God just gets in, right, and breaks the laws of nature. So that doesn't really bother me as much as some. But for some theologians, it's just a non-negotiable. God will not break his own laws. So I do try to provide a model where God can do a lot, including allowing Jesus to walk on water, that does not violate the laws of nature. Yeah.
Over here? Okay, and then we got one over here next. Lauren, pass this behind you.
Basically, the laws of nature are a statement in the language of mathematics of the property of the universe. A law of nature is a statement in the law of mathematics of a property of the universe which God put in it when he created nature. According to the Bible, that seems to indicate that these laws are stable. God was finished. It was done. Am I disagreeing with you?
I thought you were when you started, because you talked about the laws being statements, right? So I thought you were talking about like equations in a book or something. They are again divine decrees. It's things that God. Again, Genesis 1, right? God says, "Let there be light," and He doesn't create something then that goes and makes light for Him. It just it happens. When you're an omnipotent being and you want something to happen, then it happens. It's part of like the job description, right? It just happens. So yes, that's what I think the laws are. They're divine decrees, but they're more than what you are going to find in the textbooks. The stuff in the textbooks, if it's true, right? A law statement you find in a textbook, if it's true, means there is a law of nature, which in my view is something that God's decree that the law statement is getting right. I mean, it goes back to Kepler. Kepler described really science as a whole, was thinking God's thoughts after him. That's what science is, because God is using mathematics to actually put the whole thing together. We're thinking God's thoughts after him. So if we have a true law statement in a book, where we have correctly thought one of God's thoughts after him, we have described one of his decrees. So I think we're agreed. I'm not positive. The way you phrased it, the way you started it, threw me just a little bit.
Was there a question over here?
Oh, there's one over here.
When you spoke about induction and as it related to Humean and decretalism positions, you said that Humean theory was inconsistent with induction, but that decretalism was consistent.
Yes.
It seems that, to me, that decretalism doesn't guarantee the uniformity, because to the extent that we know God's will, it could be that the laws will change. Saying that the laws are a result of God's will doesn't demand that they won't change.
Yeah.
Do you have any further?
I mean, I could tell you what Descartes said about exactly that question. So I said it briefly, that God he won't have any, God will never have any reason, having decreed the laws, there aren't going to be any circumstances that come up that are going to surprise God such that he's got to change his mind, right? So having decreed the laws, and they are again, just divine decrees. Unless God had a reason to change his mind, then the laws will be stable now and from creation onward. Our theology could be wrong, our theology about God and that he's more whimsical or some such thing. So I'm not saying I can't be wrong. This is not scripture for sure. But given what we understand about God, if I'm right about the notion of the laws and the decrees, right? Something would have to change God's mind for him to change his decrees. And I don't foresee any such thing. Maybe I'm wrong. I take it that it's possible, but I'm not terribly worried about that. In which case, the decretalist has an answer to induction. Not only has nature been stable and regular, it will continue to do so, and it's God that's keeping things on the rails.
Sounds good.
Should we go with one more?
Yeah, I have a question too, but let's go with you guys.
Yeah, I'd like to ask, do you see, with regard to God's decrees, several times in the New Testament, we read that from Christ and through Christ and unto Christ are all things. How do you relate God's decrees to that, what the New Testament reveals?
That's really good. That's a really good question. And the answer is I don't. At the level I'm right, I really am just talking about, for the most part, theism, right? So monotheism. You get down into the nitty-gritties of Christian theology and the role of Jesus. I have nothing to say at this point. So it's a good thing. Is there a next step? So qua Christian, given what it says in the New Testament, should I be able to say more? Probably, but I have to tell you, I have not thought about that. I don't know how that fits into this picture, other than so you want to have like a Trinitarian division of labor. Given some of the things that the New Testament does say about Jesus, then maybe the best thing I can say off the top of my head is that it is God the Son who makes the decrees. If nature does rely on Jesus the way it seems, the New Testament seems to hint, then the exact source, right, of the laws is God the Son. Again, if I had an hour to think about it, right, I might change my mind. But that seems like a
Presumably it would be through the Word, God through the Word. Would that be fair? I mean, the three always act in concert.
Yeah. So, but it's like
unity.
it's part of what Jesus is going to. It's part of the division of labor, within the. So the Son always does what the Father wants, but the Father now is going to say, go make the laws, and Jesus makes the laws. Yeah, God the Son makes the laws. Yeah, I think
There's another lecture.
I kind of like that. that might be another paper,
There's
but
another lecture.
I like it. Yeah. You got one more?
I did have one more question, if
Yeah.
I may. So back to your analogy, you started to initiate an analogy with a stream.
Yes.
And I was actually, as a geologist, already thinking of streams.
Yeah.
So we work from human free will down to a dog,
Sure.
down to an inanimate object,
Oh.
an inanimate object being a stream.
Right.
I've always told my students that streams behave in a quasi-intelligent manner, in that what they're doing is, first of all, they're moving stuff downhill, down a slope, right? So that they're moving under gravitational constraints, to use your analogy, and rivers, if they're outside of a rock barrier or whatever, they will naturally meander.
Yep.
That meandering is actually governed by a principle of least action.
Mm-hmm.
The principle of least action is that it will maximize the energy distribution all along the length of the river by creating meanders where necessary to even out the energy distribution. So if you push it, if you cut out a meander, for example, or if you put up a dam, the river responds in a quasi-intelligent manner to conforming only to the principle of least action.
Yeah.
Otherwise, it can kind of go where it wants.
Yeah.
And is that also saying something like what you're saying?
I would want to say, where is the quasi-intelligence? I don't think in that case it's in the river.
Right.
It's in the laws
Yeah.
that the river obeys.
Yeah.
So I don't want to take intelligence and press it all the way down into inanimate objects.
Well, as a geologist, I want to do that. But,
yeah, no, I can't. I mean, it is like, not against the law. So,
no, I only did this facetiously with students, but the point being something like what you're saying is that rivers behave in a predictable manner.
Yes.
That predictable manner is a manner that is intelligible to us.
Right.
Based on these few fundamental constraints that God has instituted out there. One of those being the constraint of least action.
Least action, yeah. Least action really works. Least action is less familiar than conservation laws to most of you, I realize, but it really, this notion of constraint, that's what it does. It doesn't tell you from the initial conditions, here's how it's going to go. It's going to say it's got to fit within these constraints. That's a nice model, again, I think, for how all the laws of nature work. The laws of nature keep things behaving in a particular way. They keep nature on track. They don't push things along. The laws are not forces. They're not themselves causes.
And they're broadening that out. There was this very point was used in a dialogue between Asa Gray and Charles Darwin about the course of evolution, whether God could guide events in evolution. And Asa Gray said, rivers move stuff down slope. They meander where they will, but God may have designed the courses, right? Darwin wouldn't go along with that.
Yeah. Sorry.
Well,
wish he'd gone along with more.
I mean,
he seemed to like it early.
It seems like Asa Gray was absolutely on target.
He had some stuff to say, for sure.
Yeah. Okay. This is fascinating. Some of you may have further questions for the speaker. We would encourage those. We want to give, some of you have to go. Others may be mentally tired out. That's fine. But let's give them another round of applause. And if you have further questions, come on.
Thanks very much. I'm done?
I like it.
All right, good.
Yeah, I like it. And I think a lot of biologists who work with historical biology will.